Among the twin-engine aircraft produced by the Bristol Company that fought in the Second World War, the heavy fighter Beaufighter became the most famous. It was one of the most successful aircraft of the war. About 6,000 were built, and they were used in virtually all major campaigns from 1941 to 1945. The Beaufighter performed the roles of night fighter for defense, day and night ground attack aircraft, long-range escort fighter, and torpedo bomber. However, the development of the Beaufighter, and more importantly, its rapid entry into production, was possible only because a little earlier, Bristol had created another Beau series aircraft, the torpedo bomber Beaufort. From this aircraft, the Beaufighter borrowed not only part of its name, but also the wing, tail unit, and landing gear. The Beaufort, closely related to the Blenheim, never achieved the same fame, but it was effectively employed by Coastal Command in the early years of the war, until more Beaufighters and Mosquitoes became available. It also played an important role in the victories in the Middle East and the Pacific. Britain's position as an island supplied by sea routes led to particular attention from the Royal Air Force to torpedo bombers. The need to protect Britain's coastline also stimulated interest in the reconnaissance bomber, whose primary task was maritime patrol. As part of the general modernization and expansion of the RAAF in the mid-1930s, industry was invited to submit designs for new aircraft to fulfill both of these roles. On the eve of the war, these tasks were carried out by the Vickers Wildebeest torpedo biplane and the Avro Anson reconnaissance bomber monoplane. The specifications issued by the Air Ministry in the summer of 1935 called for new twin-engine land-based aircraft with significantly higher performance and bomb loads than the types they were to replace. One requirement outlined a 3-seat torpedo bomber, and another specified a 4-seat reconnaissance bomber. Records show that of the roughly 20 companies that made up Britain's aircraft industry, only 3 showed real interest in these requirements: Avro, Blackburn, and Bristol. As the manufacturer of the Anson, which was to be replaced, Avro naturally wanted to keep its share of the market and submitted the Type 672, a development of the Anson with 2 Armstrong Siddeley Terrier engines. Blackburn, which already had experience designing torpedo aircraft, such as the Dart, Ripon, and Shark, submitted for the torpedo bomber role a high-wing monoplane in which the torpedo was carried inside the fuselage. The Bristol Aeroplane Company, on the other hand, had little direct experience with Coastal Command aircraft, focusing mainly on fighters and bombers for the RAF. However, the Blenheim, which had entered production in September 1935, seemed to be a suitable basis for meeting both requirements. In the final months of 1935, the Air Ministry received separate proposals for each role, both based on variants of the Blenheim. For the reconnaissance bomber, Bristol submitted the Type 149, essentially a Blenheim wine with an extended fuselage, a crew of 4, pilot, gunner, navigator, and radio operator, and a slightly larger dorsal turret with 2 0.3-inch Lewis machine guns, but with the same overall dimensions. A single forward-firing Browning was mounted in the wing. The bomb bay of the standard Blenheim was retained in full, and additional racks for small bombs could be carried under the wings. With 2 supercharged Bristol Aquila engines, the aircraft had a loaded weight of 10,932 pounds and was estimated to reach 254 miles per hour at an altitude of 5,000 feet. For the torpedo bomber role, more extensive changes to the Blenheim were needed, mainly to accommodate a torpedo in the bomb bay. The pilot's cockpit was moved 4.5 feet forward compared to the Blenheim, and the dorsal turret was moved further back to keep the center of gravity within acceptable limits. The general contours of the nose remained the same as the Blenheim mirrors. This design, named the Type 150, was proposed in December 1935 and was to have a crew of 3. The radio operator was seated behind the pilot but had to move forward into the nose to aim bombs, while the pilot handled aiming for the torpedo drop and firing the wing gun. With a total weight of 11,138 pounds, including a torpedo weighing 1,143 pounds, the Type 150 with 2 Perseus 6 engines was estimated to achieve 280 miles per hour at 5,000 feet. Its wingspan was slightly increased compared to the Blenheim's 56.3 feet, reaching 58 feet, while its length was 44.3 feet. Since there was a strong similarity between the 2 originally proposed aircraft designs, the Bristol design team under L. Fries suggested in early 1936 to build one aircraft in 2 variants, each fulfilling different roles. The only major difference was the raised floor of the cockpit in the torpedo bomber, which enlarged the bomb bay by using the space beneath the cockpit. However, even with this change, it was not possible to completely house the torpedo inside the bomb bay, so a semi-recessed mounting was planned. In April 1936, Bristol formally presented this design as the Type 152. The nose was extended by 9 inches, providing room for the navigator. The radio station was placed in front of the dorsal turret together with a camera. The radio operator also served as the gunner, which reduced the crew to 3. The Type 152 was planned in versions with either Aquila or Perseus engines. The maximum loaded weight was 11,000 pounds for the Aquila version and 12,240 pounds for the Perseus version. Despite the greater weight, the Perseus version was expected to have better performance. An estimated top speed of 287 miles per hour at 5,000 feet compared to 262 miles per hour. The idea of combining the two requirements in one aircraft was welcomed by the Air Ministry, and Specification 1036 was issued. The semi-recessed torpedo arrangement was accepted, but a 4-man crew was considered essential. Bristol's designers made final changes that gave the Beaufort its distinctive difference from the Blenheim, a raised cockpit roofline extending up to the top of the turret. This allowed the pilot to sit above the forward part of the bomb bay and left space for the radio operator behind him. A dedicated dorsal gunner was introduced while the navigator was placed in the nose, where he could sit at a chart table or lie prone at the bomb site. Blackburn similarly modified its original 3-seat design to include a 4th crew member, while Avro reworked its project to fulfill the combined role. By the autumn of 1936, Bristol and Blackburn had received orders for series production directly from the drawing board. Avro's project was rejected. Both the Bristol 152 and the Blackburn B-26 were to be powered by 850 horsepower Perseus engines, which had been chosen for mass production. However, recalculated performance figures showed that the new aircraft would be slower than the Blenheim due to the added weight of required equipment. Bristol's twin-row Taurus engine appeared to be a promising alternative, offering 1,150 horsepower, but it was not fully tested and could only be delivered in small numbers because of Bristol's commitments to supply other engines. By 1937, it was agreed that the Type 152 would use Taurus engines, while Blackburn's competitor would retain the Perseus. This led Blackburn to propose the B-27 with Hercules engines instead of the B-26. Although it received no official support, the later history of the Botha, as the B-26 was named, showed that its designers were quite correct in judging the Perseus as underpowered. The decision to bypass prototypes for the Bristol and Blackburn designs was made to speed their entry into service. In both cases, the first 5 aircraft were delivered for testing and refinement, including handling trials and flight performance evaluation at the Aeroplane and Armament Experimental Establishment, the preparation of pilot's notes, and weapons testing by the Torpedo Development Unit. Named the Beaufort, with the permission of the Duke of Beaufort, soon after the production order was placed, the Bristol 152 retained a slightly greater wingspan than the Blenheim, and a very similar all-metal structure with stressed skin covering, except for the fabric-covered control surfaces. Some improvements were introduced over the Blenheim. The entire airframe was built from relatively small prefabricated units, which simplified subcontracted production. At the time of the order, the Type 152's armament consisted of a single 0.303-inch gun in the port wing and a Bristol dorsal turret intended for 2 machine guns. However, due to shortages, it usually carried only a single drum-fed Vickers K gun, or later 2 such guns together with a Syncamera gun. Additional wing, nose, and beam guns were fitted in later stages. The normal bomb load consisted of 4 250-pound bombs or 2 500-pound bombs, which by 1940, when the Bristol bomber entered service, could be high explosive, semi-armor piercing, or depth charges. The commonly quoted maximum bomb load of 650 pounds for the Beaufort referred to its ability to carry the standard British torpedo or a 1,500-pound mine. The actual maximum load was 2,000 pounds, and in May 1940, the Beaufort became the first aircraft to drop a British bomb of that weight during a raid on a German cruiser. For short-range missions, additional bombs could be carried on universal racks under the wings. The first production contract for the Beaufort was signed by the Air Ministry on August 22, 1936, covering 78 aircraft. The ministry even agreed to accept the first 5 machines without full factory equipment, treating them as experimental models. They were fitted with early versions of the Taurus engines, producing about 1,010 horsepower at takeoff and just over 1,060 horsepower at 5,000 feet. Bristol's engineers gave the engines sleek, elongated cowlings to reduce drag, but during the first ground runs it became clear that the design suffered from persistent cooling problems. Conventional cowlings with circular shutters had to be installed before the aircraft's maiden flight in October 1938. Tests soon revealed another issue. The large landing gear fairings caused unwanted yaw when the gear retracted or extended unevenly, which was not uncommon with the hydraulics of the time. These fairings were removed, and for a period the aircraft flew without them until hinged side doors were introduced. The first Beaufort spent months in trials, often returning to Filton to help refine the Taurus engine, which continued to struggle with overheating. One aircraft was fitted with dual controls for training duties, while others were lost in crashes or written off after damage, though fortunately without casualties. By late 1939, fully equipped production Beauforts began leaving the assembly line. They underwent intensive squadron testing and after a series of accidents and modifications were ready for operational use by the spring of 1940. The aircraft initially carried the supercharged Taurus Series III engines, but the less heavily boosted Series II proved more reliable for low-level missions. In its improved form, this engine became the standard. Later, Beauforts received updated versions of the Taurus with strengthened components and small refinements. As production expanded, the Air Ministry reshuffled the designations. All Taurus-powered aircraft became known simply as Beaufort FIRF, while Beaufort II was reserved for those fitted with American twin Wasp engines. Planned developments included the Beaufort III with Merlin Dexat engines and long-range fuel tanks, and the Beaufort IV with 1,250 horsepower Taurus, XX engines, and a new 4-gun turret. Orders were even placed for 500 aircraft of the fourth type in 1942, but none were built. Only one machine flew as a prototype with the new engines, and in the end, the designation numbers from V to NIX were applied to the Australian-built Beauforts. At first, only 78 Beauforts were planned at the Filton factory, but the order quickly grew to 350. On top of that, the RAAF ordered another 90 aircraft for Australia, intended to strengthen the defense of Singapore. Yet by the time Japan attacked in late 1941, only 6 reached the base, and most of those soon returned to Australia. As a result, the Australian Air Force kept all locally produced Beauforts for itself. To replace them, the British Air Ministry ordered 90 more from Bristol, of which most were built as standard versions, while a handful became the first improved Beauforts. In total, more than 1,000 Beauforts were produced at Filton. Production soon reached an impressive rate of 30 aircraft a month, the fastest of any British bomber of the Second World War. Combat experience brought many improvements. Bombing accuracy was increased with better aiming equipment, and the aircraft's armament was steadily strengthened. Extra guns were fitted in the wings, nose, and sides to defend against enemy fighters. Cameras and radar were also added for reconnaissance and anti-shipping missions. The airframe itself was reinforced, and on Australian-built Beauforts, the tail fin was enlarged, giving pilots better control when flying on one engine, often a life-saving measure. Engineers even experimented with special air brakes to steady the aircraft during torpedo attacks, but these proved unreliable and were soon abandoned. By the end of 1943, production in Britain wound down. The last batches, assembled with American twin Wasp engines, were used mainly as training machines, fitted with dual controls instead of heavy combat equipment. The very last Beaufort left the factory in late 1944. In total, 1,429 were built in Britain, with many more produced in Australia. At the beginning of 1939, a British aviation mission visited Australia to discuss with the Australian government measures to strengthen regional defence. They wanted to understand how the aviation industry of the Commonwealth countries could assist in this. The Bristol Beaufort aircraft became the first candidate for production in Australia and used by the Royal Australian Air Force. This aircraft was an ideal choice for several reasons. Firstly, its design allowed for easy distribution of parts manufacturing among various existing enterprises, even including railway workshops. Secondly, its flight performance was well suited to Australia's coastal defence needs. Because of this, the Department of Aircraft Production created a special Beaufort division to oversee the production of the first batch of 180 aircraft. The order was placed on July 1, 1939. Final assembly was carried out at 2 centres, one at Commonwealth Aircraft Corporation in Fisherman's Bend, and the other at a new plant in Mascot. Half of this order, 90 aircraft, were built to the technical requirements of the Royal Air Force as the Beaufort MKE. They were to replace older aircraft in 36 Squadron and a fallen 100 Squadron in Singapore. The other 90 aircraft were built to similar requirements but for the Royal Australian Air Force. The Bristol Aeroplane Company supplied the drawings, tools, and equipment for aircraft production. Taurus engines, turrets, instruments, and some major components were to be imported from Britain. In October 1939, a sample aircraft, the 8th production Beaufort, was sent. Under the agreement, 20 complete sets of parts were to be delivered for the assembly of the first aircraft in Australia. Anticipating that the supply of engines from Britain might prove impossible, the Australian government decided at the end of 1939 to use the American Pratt & Whitney twin Wasp engine instead of the Taurus. The British Air Ministry designated this variant the Beaufort Mach-E II. These aircraft, which were to be built in Australia in place of the original 90, already received British serial numbers. The equivalent variant for the Royal Australian Air Force was now called the Beaufort MKV. The first flying prototype took to the air only on May 5, 1941. Deliveries of Australian-built Beauforts, partly assembled from British-supplied components, began in August 1941. By December 1941, 6 of these aircraft had reached Singapore, where they were to be used by Royal Air Force squadrons. One of them was sent to Kota Bharu in Malaya to be used as a special reconnaissance aircraft under the direct command of the Air Force headquarters in Singapore. This aircraft was written off after completing a mission photographing Thai territory. The others could not be used because the crews had not been trained and the aircraft were not fully equipped. They later returned to Australia and were included in the Royal Australian Air Force order for Beauforts. The first 50 Australian-built Beauforts, known as the MKV, had twin Wasp engines manufactured in Australia by General Motors Holden, along with Curtiss electric propellers. A temporary shortage of these engines led to the production of 100 aircraft with imported engines. Of these, 40 were Beaufort Mach-E 6 with Curtiss propellers, and 60 were Beaufort Mach-E 7 with Hamilton Standard propellers. Production then continued with the Beaufort Mach-VA, which had locally built twin Wasp engines and Hamilton Standard propellers. A batch of 30 of these machines completed the initial contract for 180 aircraft. An additional order was then placed for 520 more Australian aircraft, designated the Beaufort Mach-E RAAF. They were equipped with Australian-built twin Wasp engines and Curtiss electric propellers, British radar, fittings for British or American bombs and torpedoes, a movable nose gun mount, additional fuel capacity in the wings, and a Bristol dorsal turret with twin 7.7mm machine guns, or, on the last 140 aircraft, an Australian turret with twin 12.7mm machine guns. Deliveries of the Beaufort Mach-E 8 began in November 1942 and continued until August 1944, reaching a production rate of 30 aircraft per month. This was comparable to the maximum output of the main factory in Britain. In the final months of the war, several Beauforts had their dorsal turrets removed and replaced with fairings. They were used for transporting cargo or passengers. 46 such conversions were designated Beaufort Mach-E 9 and received new serial numbers. One of these aircraft flew with an extended fuselage containing a cargo container but was later brought to standard Mach 9 configuration. All Australian Beauforts had a fin of increased area. It was introduced into production with the 91st aircraft, Cushion, and was also retrofitted to earlier machines. Despite the decision to proceed without prototypes and the important fact that the Beaufort used components from the Blenheim, especially the wing, the total time from the initial idea, August 1935, to the start of production, October 1939, turned out to be only slightly shorter than for other aircraft. It was only a month or two faster than the development of the Manchester or the Halifax. By the time deliveries began, the need for these aircraft had become critical. At the end of 1939, 22 Squadron of Coastal Command, which was supposed to receive the first Beauforts, was forced to use its obsolete Wildebeest biplanes to cover the ship carrying King George VI to France and back. Under the circumstances of the time, problems with bringing the Beaufort into service were inevitable, and indeed they arose. The first aircraft to reach 22 Squadron, it was the 7th built at the factory, arrived at Thorney Island on November 15, 1939. 4 more arrived by the end of the month, but as mentioned earlier, 2 of them were written off by the end of January. The aircraft had the unpleasant habit of swinging sharply during takeoff, which caught out many inattentive or insufficiently experienced pilots. It barely flew on one engine, was prone to catching fire during crash landings, and its engines, which produced barely enough power for the Beaufort, were extremely unreliable. In addition to bombing and torpedo attack trials at government research establishments, 22 Squadron also conducted them. It turned out that torpedo release required low-level horizontal flight rather than a dive attack to ensure the torpedo traveled correctly just below the water surface. Test bomb drops revealed instability during bombing from high altitudes. "This is a very poor bombing platform," one test center report stated, after bombs were dropped from 10,000 feet at a speed of 238 miles per hour. However, at low altitudes, the problems were less severe. For practice in dive bombing, 22 Squadron trained to drop 1,500-pound naval mines from 500 feet at a speed of 200 miles per hour. With this weapon, the Beaufort went on its first combat mission of the war. On the night of April 15, 1940, 9 aircraft from 22 Squadron took off from North Coats on the Lincolnshire coast to lay mines in the Schillig roads north of Wilhelmshaven. One aircraft did not return, but whether this was due to enemy action or engine failure remained unknown. 2 nights later, Beauforts of 22 Squadron made their first bombing sortie. In the following months, bombing raids became the main activity both by day and night. In April 1940, 42 Squadron began to receive Beauforts in place of their wildebeests. In May, it was transferred to Wick in Scotland to conduct operations over the North Sea. The unreliability of the engines reached a critical point, and all Beauforts were grounded until the Bristol Company solved the problem. They remained grounded until August, with one important exception. On June 21st, the German cruiser Scharnhorst was detected off the Norwegian coast and damaged by torpedoes from the submarine Clyde. 42 Squadron received special permission to send 9 Beauforts against this target. They attacked the Scharnhorst with 500-pound armor-piercing bombs without definite results. The engines caused no trouble, but 3 Beauforts were shot down by German fighters flying from Norwegian bases. As the Beaufort was improved, the engines caused fewer problems. 22 Squadron concentrated on torpedo attacks, carrying out the first such attack in the Royal Air Force during the war on September 11, 1940. 5 aircraft attacked a convoy of 3 ships off Ostend, scoring 1 hit on a vessel of 6,000 tons. In the period immediately after the Battle of Britain, enemy shipping was one of the most important targets with regard to a possible invasion of Great Britain. The Beaufort squadrons, which had grown to 3 by the end of the year, were constantly in action. 42 Squadron, operating from Scottish bases, and 22 Squadron on the east coast of England worked against targets in the North Sea, while 217 Squadron, which had joined the Beaufort force, operated in the English Channel and its western approaches, flying from Thorney Island or Cornwall. When, in April 1941, an opportunity arose to strike with torpedoes against the battle cruiser Gneisenau, which had been forced to leave the safety of a dry dock at Brest due to bomber command raids, 22 Squadron was selected for the task because its crews had more experience than those of 217 Squadron. 6 Beauforts were transferred from North Coats to St. Eval for the mission, which began on the morning of April 6th. Only 4 aircraft took off, the other 2 having become stuck in soft ground. Only 1 Beaufort, piloted by Flight Lieutenant K. Campbell, found the Gneisenau. Despite facing intense and accurate anti-aircraft fire head-on, he did not turn away and successfully released a torpedo from about 500 feet before being shot down. The Gneisenau was hit below the waterline, and its repair took several months. The Beaufort's pilot and observer were posthumously awarded decorations. 3 squadrons fought during the first half of 1941, combining bombing, mine-laying, and torpedo attacks depending on needs and opportunities. Losses during operations were inevitable, but flight accidents constantly added to this list as well. Commenting on a forced landing of one of his crews, the commander of 42 Squadron remarked that, "It is absolutely impossible for any Beaufort to stay in the air on one engine." It seemed that only fitting more powerful Taurus engines to the Beaufort MKI aircraft, or replacing them with the new Beaufort Maquis des Agdes, could improve the situation. The new Beaufort Maquis des Agdes aircraft were indeed received by the 4th and last squadron to fly them in the United Kingdom, 86 Squadron. This occurred shortly after it took the place of 22 Squadron at North Coats in the summer of 1941, while the latter was preparing for overseas deployment. 2 other units, 415 Canadian Squadron and 489 New Zealand Squadron began training on Beauforts at Thorney Island at the end of 1941, but before entering combat they were re-equipped with other aircraft types. The Beaufort began to be withdrawn from frontline service in the United Kingdom at the end of 1942, but in the first months of that year it took part in several important operations, although without major success. These included the failed operation in February against the German heavy cruisers Scharnhorst and Gneisenau, which, accompanied by the cruiser Prinz Eugen, broke through the English Channel into the North Sea. There was also an unsuccessful strike against the Prinz Eugen in May when it was returning. All 4 squadrons that had flown Beauforts in the United Kingdom were eventually sent overseas, but the type continued to be used in Britain as a trainer until the end of the war. The first unit to use the Beaufort in this way was the Coastal Command Training Unit formed at Silloth in early 1940. Later, several other training units and the 5 Air School in the Middle East joined in. 2 torpedo training units flew Beauforts, as did other specialized training formations. For some time, the latter used Beauforts fitted with radar for training purposes. These training units employed all marks of Beaufort, not just the dual control trainer versions. Examples of the latter were at 12 Flying Training School in 1945 and in some specialized training units until June 1946. The Fleet Air Arm also used trainer Beauforts, employing 38 of them to train navigators in the final year of the war. The first Beauforts were declared obsolete in 1944 and the Maquet second series in July 1945. After nearly 2 years of flying Beauforts, 22 Squadron had gained the reputation of being a very experienced unit when in March 1942 it was sent overseas. Initially it was intended to send them to Singapore, but before departure the destination was changed to Ceylon. In fact, the squadron was held up en route to India and Ceylon in the Middle East due to the urgent need to reinforce bomber forces operating against German General Rommel. By the time 22 Squadron reached North Africa, another Beaufort unit, 39 Squadron, was already operating there. It had been re-equipped from Maryland aircraft directly in the Middle East and was conducting bomb and torpedo attacks on shipping in the Mediterranean, sometimes detaching elements to fly from Malta. 22 Squadron carried out several operations together with this unit before moving on to India. Following them to Malta in May 1942 was 217 Squadron, also originally sent to Ceylon, but immediately diverted back into the Mediterranean battle, where it operated until the end of July. 42 Squadron left the United Kingdom in June 1942 to head to the Far East, but was likewise diverted to the Middle East. There it joined 47 Squadron, which entered combat in October 1942 as a newly formed Beaufort unit operating from bases in North Africa. 86 Squadron was sent to Africa in July and began operating from Malta alongside 39 Squadron and a detachment of 217 Squadron. After the latter was withdrawn, surviving aircraft of 86 Squadron were used to reinforce 39 Squadron. All units based on Malta during this period suffered heavy losses. As a result, 86 Squadron was forced to cease operating Beauforts. 39 Squadron and 47 Squadron remained the 2 Middle Eastern units flying Beauforts, continuing operations until re-equipment in mid-1943. 22, 42, and 217 squadrons reached their destination in Ceylon, from where they carried out patrols guarding Allied shipping in the Indian Ocean. Continuing to use Beauforts until mid-1944, they did not conduct a single torpedo attack, as enemy ships did not come within their operational range. As is often noted, the first Australian-built Beauforts were initially handed over to the Royal Air Force, but were soon absorbed by the Royal Australian Air Force. About 3 months after Pearl Harbor, the Australians formed their first Beaufort Squadron, naming it 100 Squadron after the British unit of the same number, which had been almost completely wiped out in Singapore before it had the chance to receive more modern equipment than the old wildebeests. An intensive training program carried out at bases in northern Australia and New Guinea brought the squadron to operational readiness in mid-July 1942. The first mission was flown on June 25th. 5 Beauforts bombed Japanese shipping off the coast of New Guinea, while 2 others bombed Lae. 1 did not return. The same unit carried out the first torpedo attack by Australian Beauforts on September 7, 1942, but all missed their targets, Japanese vessels that had sheltered in Milne Bay on the southeastern tip of New Guinea. Throughout 1942, 100 Squadron remained the only Royal Australian Air Force unit flying the Beaufort. These aircraft carried out a variety of missions, bombing enemy targets, attacking ships with torpedoes, and conducting reconnaissance while continuing pilot training. The first major success came on January 6, 1943, when during a night torpedo attack, 2 enemy transport ships were sunk and a destroyer was damaged. However, this cost the loss of 2 Beauforts. The latest Beaufort Mi-8 models, the final production version, began to arrive with 100 Squadron in the spring of 1943. The same aircraft were received by 6 Squadron and 8 Squadron, which had begun re-equipping but were not yet ready for combat. Several Beauforts were meanwhile added to the Hudsons of 7 Squadron and 14 Squadron, which conducted reconnaissance from Australian bases. 100 Squadron continued intensive combat operations until September 1943, suffering heavy losses. Then 8 Squadron entered combat, flying its first mission on September 22nd. 6 Squadron joined them a few days later. All 3 squadrons were used mainly for direct support of ground forces and low-level strikes against land targets, rather than for anti-shipping attacks. This became the typical tactic for Royal Australian Air Force operations in 1944. The installation of a turret with 0.50-inch machine guns on the Beaufort Mi-8 significantly increased its firepower. Increasingly incendiary, anti-personnel, and fragmentation bombs were carried as loads against Japanese ground forces in 1944. In 1945, 7 Squadron was moved into the combat zone, while 1 Squadron and 2 Squadron, which were based in Australia itself, received Beauforts. Finally, 15 Squadron was also re-equipped with Beauforts and managed to see combat before the end of the war. The type was also used by 13 Squadron and 32 Squadron, as well as training and specialized units, including 9 Air Supply Unit. Although service in Britain and Australia accounted for the bulk of the Beaufort's wartime career, the type also served in the South African, Turkish, and Canadian Air Forces. A total of 18 Beaufort Mke aircraft were delivered to the South African Air Force at the end of 1941. They were used to equip 36 Flight in Fulls and partially 37 Flight of Coastal Defense. These units later merged into 20 Squadron, with a mixed strength of Beauforts and Marylands. This squadron took part in the occupation of Madagascar in May 1942, where it operated until November, and in September it was renumbered 16 Squadron. 15 Beauforts were delivered to the Royal Canadian Air Force in August 1941. They were used by 149 Torpedo Bomber Squadron for coastal defense in Western Canada. Several aircraft also served with 32 Operational Training Unit at Patricia Bay. The Canadian Beauforts were rarely used for anything other than patrols, and all were withdrawn from active use by October 1944. A batch of 12 Beauforts was delivered to Turkey at the end of 1944, when that country broke off diplomatic relations with Germany. These aircraft were taken from storage in the Middle East and flown to Turkey via Iraq. They saw little use in the Turkish Air Force, but a batch of 12 Beaufort Mekki trainers delivered in 1945 remained in training units until 1947. Thus, the handful of aircraft in Turkey appear to have been the last Beauforts still flying, although some Australian machines remained in service after 1946. Today, no British-built Beauforts survive, but some large components from Australian Beauforts are held in the United States. Supplemented by parts recovered from crash sites in New Guinea, they may provide the basis for the restoration and preservation of the only complete example of the first Beau family aircraft built by Bristol, the predecessor of the famous Beaufighter. This was an aircraft that played an important, though unglamorous, role in the Second World War. The Bristol Beaufort was a 4-seat, twin-engine, all-metal aircraft with a mid-mounted wing. The fuselage had a smooth aluminum skin. In the forward section was a well-glazed navigator bomb aimer station. On the right side was a set of navigation instruments, on the left a bomb sight. In the nose glazing could be mounted 1 or 2 Vickers machine guns on a movable mounting for forward defense manned by the navigator. The crew cockpit had 2 seats and was connected to the navigator's compartment. The bomb aimer could take the seat to the right of the pilot and assume control of the aircraft. Behind the pilot sat the radio operator and radar operator. The gunner's position was in a fully rotating glass turret armed with 2 Vickers machine guns with electric power drive. The tail unit was of conventional type. The control surfaces had aerodynamic balance and were trimmed in flight by fabric-covered trim tabs. The wing was of all-metal construction with 2 main spars and a smooth, stressed skin. It consisted of a center section and outer panels attached at a 4-degree dihedral. Between the spars were fuel tanks, 2 in the center section and 2 in the outer panels. Circular oil cooler intakes were built into the leading edges of the outer panels. In the left panel were also installed a synchronized fixed gun, a gun camera, and a landing light. To the rear spar were attached 4-section metal flaps and fabric-covered ailerons. The power plant consisted of 2 Bristol Taurus 14-cylinder twin-row air-cooled radial engines of either the Make-E or Make-Your series, each rated at 1,065 horsepower. On the Beaufort Make-Poitud modification, up-rated Taurus Make-1000 or Make-1000 engines were fitted, with maximum output increased to 1,135 horsepower. The propellers were 3-blade all-metal constant-speed units of the de Havilland type. The landing gear was of conventional tailwheel type. The main units with oleo-pneumatic shock absorbers retracted rearward into the engine nacelles and were covered by 2-section doors. Retraction and extension of the gear and flaps was operated hydraulically. The tailwheel was self-aligning and remained fixed in flight.